No problem.
Thank you,
You
sir.
had introduced me yesterday, na? They are the same people, right?
Yes, yes, sir. Same people, sir.
Then no problem. I'll start.
Yes.
Yeah.
Okay,
Yeah.
sir.
You all know me, no?
Yes, sir.
I mean, Shikha knows me, but anybody else? Priyanka, Mahindra Jain, Dr. Lokesh, Shivangi.
Yes,
You
sir.
don't need me to introduce, right? Chali, let's start. So, who will give me a small revision what we did last time? Yesterday, what we did? Anyone? Anyone wants to say what we did in the last time? Yesterday, what were the major points we discussed? Anyone who would like to start? Anyone? We discussed green energy, right? So, what were the basic difference in green energy? What were the other issues we discussed? Anything you want to say?
So we did the difference between green energy and sustainable energy.
Okay. Anything else? What other points and activities we worked on? Actually, no problem. Let's start. So what we did was, if you look at carefully, let me share my presentation with you. Uh, Where did it go? Yeah, session one. Yeah. Because today what I'm going to do here is it will be linking to this what I have done. Okay. So do this. Yeah. You can see the presentation.
Yes, sir.
Yeah. So now if you look at carefully, just a minute, yeah. So what we discussed about green energy and sustainability. So last time yesterday we also discussed about this particular part, why green energy and sustainability is so important. So we discussed population increase, we discussed the future growth happening. We also discussed that means that how much more output is going to come. So we did a small quiz also from Tata Power's activity. Then we said there's a difference between green energy and renewable energy. So they are not simultaneous, they are different, correct? So solar and wind are originally replenished continuously. Infrastructure construction will result in carbon emissions, and true green energy has minimum environmental impact. We also discussed something about the core definition of green energy. We also discussed the strategic context. We discussed what we mean by natural, renewable, and energy friendly, sustainable long term activity. We discussed. So then we discussed that why this is so important here is if you look at the current activity, around 80% is the fossil fuel dependency today, and that's uh, very difficult because once I'm after this, when we are going to discuss about green finance, green EV, and when we are discussing something interesting about green buildings, correct? That's a very interesting topic we are going to cover today. You'll find why I'm telling you because as population increases, people need more vehicles to drive, people need more houses to be built, correct? So even those vehicles and houses have to be green, using green energy, right? So we are going to discuss that activity also. So fossil fuel dependency, then 90% is the emission share of total energy CO2 attribute to fossil fuel combination. So if 80% of your energy is fuel dependent, fossil fuel dependent, 90% of the emission share is due to the CO2 emission due to fuel emission. 30 billion annual tons of CO2 emission takes place, and the temperature will go to 6.4 degrees centigrade. Now, I said something very interesting, but by 2100. Then I said something very interesting. If you don't have to wait for 6.4% per degree increase, even if it increases by 1.5%, gone. We all are actually gone. So then we said that there are huge cascading environmental impact and economic growth paradoxes there. So we have to be very important and taking care of using green energy. So we discussed multiple activities like solar energy, wind power, hydraulic, and geothermal. And Then we discussed that for a compensation benefit for sustainable development, we need to have something called environment protection. Means green energy system produce dramatically lower life cycle emission compared to fossil fuels. And non-combustion based technology generate electricity, virtually zero air pollution, and protecting human health, ecosystem from toxics, particularly from sulfur dioxide, nitrogen, and things like that. Then another system came out is called energy security, like diversifying energy portfolio with domestic renewable resource reduces dependence on important fossil fuels, enhancing national energy interdependence, and the distributed nature of renewables provide resilience against supply disruption and price volatility in the energy market. So very interesting way, like for example, earlier how a person used to decide on oil. Now oil has become, to be really frank, a very concentrated activity, only three regions. Now, I will not say three regions now, it's the US and Russia to be more precise. OPEC has slowly leading because once Venezuela is under US, then I don't think they require Middle East to be so activity. So these are the very interesting way to decide how energy security need to be managed. Like just imagine once upon a time, I don't know if I have a video. Let me show you if I have that video. Let me see if I have that video. Once upon a time, how the oil price used to be decided. So somebody used to say that, you okay? You want what is the value you want to give? I said until $10 per barrel. So okay, fine, you can have $10 per barrel, correct? So there was nothing called as a thing. Then OPEC said that, then one of the Saudi countries said that what we'll do here is why let us combine together and form an organization called OPEC. And when OPEC was formed, then the pricing thing was decided, and the whole activity and process actually changed. So I just want to show if I have it here. It's very interesting because energy security is very important because that links directly to green energy and activity, where we per se are more sustainable than anything else. Let me see if I have that with me. If it is not there, there's no problem. So I have no perspective altogether. There's another thing which I'll show you a little later. Yeah. Yeah, so let me show you the small one, and then we can discuss it further, why we talk about energy security and things like that.
$110 for us.
Are you able to? Sorry. Are you able to see this? Let me.
No, sir. We are not able to see anything.
Can you see it now?
No, sir.
No, sir, your video is also gone.
No, you're not able to see anything.
No, sir.
Only your audio, sir.
Okay. Now.
Yes, sir.
Just have a look at this video and then we'll discuss what we mean by energy security.
$10, $60, $45.
Are you able to hear it also?
Yes, sir.
Yes, sir.
Once upon a time, oil was sold in America for as cheap as 1 cent per liter. 50 years ago, these countries produced most of the oil. Venezuela, Saudi Arabia, Iran, Iraq and Kuwait. They sold their oil at whatever price they got.
My price is $10 a barrel.
But other countries are selling their oil for $9.
Okay, here take mine for $8.
1 barrel equals 159 liters of petrol. Soon, the whole world wanted more and more of their oil.
We have to charge higher prices for our oil, but how?
In 1960, these 5 countries formed a group.
Our group will now be known as the Oil Producing and Exporting Countries, OPEC for short. and together we'll sell our oil at only one price.
8 more countries joined them, and the price of oil suddenly shot up. Other countries like UK and Russia also found lots of oil.
We're not part of OPEC and will decide our own price.
The world was soon flooded with more oil from more than 15 nations, keeping price low at about $40 a barrel.
Buy my oil. No, buy from me.
But that was about to change. 15 years back, when the US, China and Europe were growing, they needed lots of oil. This made the price rise. When the price of oil increases, the cost of transporting goods from the factories to shops rises. By road, by sea, by air. From end 2003, the price of oil began jumping up. As India is the 4th largest buyer of oil in the world, prices of foods and vegetables began to rise. The USA also makes oil, but use more than they produce, so they too faced rising prices. Rupees 70 per litre. But countries that were selling the oil, oh boy, they were having fun. Building malls, fancy buildings, giving almost free petrol to its citizens. As it so often happens, no party lasts forever. 2011 in the US.
We have discovered a new way of removing oil from under the Earth's crust. It's called fracking. And while it costs over $100 to buy oil, we can now make it at $60.
China and Europe, that only 10 years back required large amounts of oil.
Business is not good, so we don't need as much oil as before.
With these two blows at the same time, the price of oil began to drop. The biggest oil buyer, USA, was now going to become an oil seller.
By 2020, we'll make more oil than we need.
Today, these 3 countries make the most oil. 11 million barrels, USA. 10 million, Russia. 9 million, Saudi Arabia. Now it was the turn of oil-producing countries to feel the heat. Their citizens were used to cheap petrol and low prices, so when the price was raised, they were angry.
We want cheap petrol. We want cheap petrol.
Countries like India were very happy with lower oil prices and have saved crores and crores of rupees. For the first time, 1 litre of air fuel cost less than 1 litre of petrol. Now I can travel without worrying about the cost. Prices from other sources of energy are falling. Solar energy, wind energy, making sure oil prices cannot rise very fast. The price of oil keeps rising and falling, but it seems that oil will remain cheaper than it was before.
So when you saw this, why I wanted to, one of the things which becomes very critical, especially when you are talking about energy security and other activities, you have to look at multiple factors which is affecting that to grow. There is an energy security is a very, very critical part. Like we have done something called as saving energy and oil security, saving parameters which we have developed and things like that. So in the same parameter, renewables also have to be done because, see, please understand something. We have to diversify our portfolio. As a country, India has to diversify our portfolio. with the renewable sources reduces dependence on important fossil fuels. You saw a small video which actually tells you about uncertainty being there for multiple activities. Then the distributed nature of renewables provides resilience against supply disruption and price volatility in international energy markets. Economic opportunities. The renewable energy transition creates millions of new jobs in manufacturing, installation, maintenance, and innovation. You would be really astonished, like Solar Abhiyan, which Government of India has launched. They have brought Aditya scholarship schemes, which they have done. Subsidy scheme, which they have done. The new activity which they are trying to develop from renewable energy, sea energy, wind. They are working on a grid perspective, investment into EV. It's not a green energy EV, but still I can say that it's something more of a better than oil, to be more precise. That has increased huge employment. Like for example, 1 million people in India initially got it, and now I believe it is growing at approximately 19% CAGR. Very interesting way to look at it. Local community also benefit. Like for example, we are doing some research. So the aggregation, the type of special ethanol, for example, look at Nasik and Nagpur. So look at how the growth perspective on ethanol utilization is happening, how they're using agriculture to work it out. And local communities' growth is also increasing. Local communities benefit from energy producing previously concentrated in distant extraction sites, enabling economic decentralization and rural development. So when we look at this, so there is a nexus between green energy and sustainable. The nexus is the concept of sustainable development through sometimes elusive and precise definition has achieved remarkable global consensus since the landmark of 1987 Butstand report articulated its foundation principle, which I last in the day for yesterday's session. This was the last slide we discussed. Development that meets the need of present without compromising the ability to future generation to meet their own needs. So we have defined this as a definition. It means development that meets development, economic, social, whatever you talk about, that meets the need of the present without compromising the ability for future generation to meet their own needs. And this deceptive, simple formulation encompasses profound implication of how humanity approaches economic progress, social equity, and environmental stewardship simultaneously. So hence, they came out with the three pillars of sustainability. One was economic sustainability, second was environmental sustainability, and the third was social sustainability. So we discussed in the day for yesterday's session, what is economic, environment, social, correct? And what do we mean by energy systems? So we discussed about energy economic growth, energy human development, energy employment. All these activities we are discussing. Just imagine 34 plus million new jobs globally in renewable sectors and related industry and growth. Then we also mentioned something about expanding energy access to underserved populations. So if you do that more, like for happened in Gujarat. So wind energy, to be more precise, has given underserved population energy access, right? So you need to develop something called decentralized solution. Unlike fossil fuel infrastructure requiring centralized generation facilities and extensive transmission network, many renewable energy systems operate efficiently at small scales. Village level microgrids powered by solar panels and micro hydraulic installation can provide reliable electricity for lighting, refrigeration, telecommunication, and productive usage. And this decentralization empower local communities, reducing dependency on distant utilities and extreme rural development. Correct. Today itself, I'm in Pune today, and we saw one hydro plant in near Bhima Shankar. Correct. So we are doing some impact analysis study for a hydropower project activity. Very interesting thing came out, how the local communities growth activity generation thing. I never thought that you could grow rice in hills. Correct. In rocky hills, correct. Yeah, hills we have steep step agriculture, so there we can do, especially in northeast as well as in Himachal and other places. But I never thought in a rocky mountain, volcanic eruption mountain, you can have excellent rice. That's called Indravati rice. So that's a very, very different way of looking at it. And now they're having multiple outputs from the same activity. So a lot of impact and things has come from there. And economic accessibility, like rapidly declined cost of renewable technology, particularly solar photovoltaic, have made green energies increasingly competitive with and often cheaper than fossil fuel alternatives, especially when external environment and health costs are considering. And so there are two things here is one called social return on investment. And that's the reason social returns on investment to renewable energy. So it's not only about cost, which I'll be sharing a little later. I'll be sharing about different cost structures and other activities a little later. Very interesting analysis, you will find it out. And there you will find out that how this thing is really helping them to grow in a very cost may be little higher, but if you look at the social impact, it is far more better. So off-grid solar system can now provide affordable electricity for millions of previously unserved households, demonstrating that energy access and environmental sustainability are complementary rather than competing objectives. So we said that the critical contribution for sustainable development to enhance national energy security, we talk about supply diversification, domestic resource utilization, and price stability. So we said, okay, uh, green energy expand the portfolio of available energy resources, reducing the over reliance on single fuel type or import source. Like 80% is fossil fuel in India. So we have to reduce that dependence on oil. And I'm going to show you the recent figures also, that how energy demand in India is made and how the future thing we need to do it so that those fossil thing to reduce, and energy renewable to increase, but green energy to be more of the part of renewable energy. Then domestic resource utilization, like unlike concentration fossil fuel reserves, renewable energy potential is distributed globally. Very nation possess some combination of solar, wind, hydro, and biomass resource that can be developed domestically. And naturally, we have to reduce the dependency of imports, and then price stability. So, like we just saw the thing of oil price goes up and down, up and down. So, one infrastructure is installed, renewable energy enjoys essentially zero fuel cost, providing long-term price certainty. This contrasts sharply with volatile fossil fuel market subject to supply disruption, correct? And OPC decision and geopolitical conflict. So, what currently we are seeing, green energy is the reply for us to manage these activities. A lot of uncertainty. But if Trump says 500% tariff if you import oil from Russia and all thing of India, there'll be a huge problem. Even if 46% to 44% our economy is export dependent, but then there's still a big issue, and US is a very big constraint of Indian export orientation activity. So we have to diversify not only energy need but also diversify our risk in international exports. So that's the reason we said that when you look at mitigating climate change and protecting environmental quality, so how much fossil fuel, how much emission growth is happening year on year, and adding emission into that line is a very different way of looking at it. So, so there are few things. This is slide is very important. Navigating barriers to green energy development. So despite compelling advantages, the transition to green energy faces substantial obstacles rooted in economic structure, information asymmetry, social dynamics, and market configuration. Understanding these barriers is essential for designing effective policies that accelerate renewable energy adoption while addressing legitimate concern and constraint. So what are those barriers in green energy deployment? One is called economic barriers. Upfront capital requirement for renewable infrastructure, undervaluation of environmental externalities in energy pricing, uncertainty about future policy support, and financial risk from unproven technologies in developing country context. If a president change, he changes the whole energy policy. Now, no funding for renewable energy, green energy in US. Today, if your newspaper you have read, he has withdrawn all the money funding for even UN climate change. So uncertainties are there. So, but you still have to make your country happy, right? And efficient and effective. So that's the main thing. So there are economic barriers. Then information barriers, insufficient large-scale data on renewable resources, wind, speed, solar irradiation, geothermal potential, lack of technical expertise for system design and operation, limited training, opportunities for workforce development. So we need to focus on these informal barriers. There are also social cultural barriers like community resistant to visual impact or land use changes, competing priorities for agriculture or urban land, inadequate consideration of local values and traditional practices in project design, concerns about equitable benefit distribution. So people still have a question, if you're doing mere paas nahi aayega, equal distribution nahi hoga, price बढ़ जाएगा, whatever you talk about. And then market structure barriers like centralized monopoly utilities resistant to distributed generation. You'll be really astonished that if you look at Europe, now earlier they made utilities firm as a private firm, but now it's all government oriented firms. Centralized monopoly utilities resistant to disruptive generation, regulatory framework designed for conventional power system, lack of grid interconnection, standard for renewables, limited competition in energy markets. So very interesting way to look at these things which are coming into thing. So economic barriers I've already discussed, so I don't want to discuss much. But I'll be discussing the government policy towards green buildings and green EVs. We have to understand few very important activities here. Innovative. Now, before we go, anybody wants to give any inputs in this? You have personally saw it, and you have some issues regarding sharing some example regarding economic barriers, information barriers, social culture barriers, and market structure barriers. Anyone? If you, because you must be doing this, right? So, any thing you would like to mention here? Anything you have experienced? No?
But not sort of barriers,
Mm-hmm.
uh, but no transmission, because the wind, especially the wind turbines, they are located far off. The wind production happens far off the place where the electricity requirement is there.
Yeah.
So much of the power gets lost by transmission.
Okay. Yeah.
Let's say
That's.
wind turbine is 20, 25, 30 kilometers away, and much of the power gets lost. So, what the wind turbines claim that, okay, this much is the power generation, but what the company which which invests in the wind turbine, what it gets is much lesser. So many a
Okay,
times
that's
there
what
is.
you're saying is correct. Yes, what you're saying is correct. Yeah.
Yes. So many times there are apprehensions from the company side to invest, because they are not, as such, they are not sure that how much is it going to produce and all. But because they get some tax concessions and some goodwill sort of thing, they want to invest in the wind turbines. But later on, they come to know that yes, there are a few issues. Information asymmetry sort of thing,
Hmm.
which
Yeah.
might
That's a
be
good point. That's a
preventing.
good point you have mentioned.
uh,
Yes, that's a good point you have mentioned. Yeah.
which might be preventing the people from investing in the wind turbines. And then other issues like noise, shadow flicker, even the birds, if they are in the path of birds migration. So this can be the few things which can act as a barrier when people want to invest in the wind turbine.
I fully agree with you. It's an excellent way to mention that. Yes, true. Um, to understand things more better, let us go forward and uh, look at some different activities. For example, if I look at economic barriers in detail, is innovating financial mechanism. Like yesterday, one gentleman was mentioning about green financing, right? So I'll be sharing a small part of green financing today. Then public-private partnership, it's more important rather than government investment in whole. Carbon pricing through taxes or cap or trade system that internalize environmental cost. Removal of fossil fuel subsidies estimated at hundreds of billions of dollars annually. Feed-in tariff, power purchase agreement providing long-term revenue certainty, and technical assistance for project development, risk assessment in emerging markets. So these are the one thing when you look at economic barriers in detail, and then how to address information and technical capability gaps. We have mentioned that. I also mentioned that a specialized knowledge of optimal performance and training for engineers, technicians, things are required. So one thing which comes out very clearly here is the policy strategy for accelerating green energy transition. You have to have very strong policy commitments like binding renewable energy targets with clear timelines. Now we have a timeline, but we extended it to 2070 because we have 200 years of coal with us. We can't just take out coal. We can't just stop using coal. Thermal power is, I'll be sharing with that the power generation per se. Thermal power is the highest value of power generation. Then comes hydro, then comes other activities and things like that. Then now we are thinking about nuclear and things like that. So we have to have a very clear timelines and long-term policy stability, reducing investment uncertainty. So we have to have very clear timelines. Carbon pricing mechanism, internalizing an environmental cost, and phase out schedule of fossil fuel subsidies. Institutional support, we need to have dedicated renewable energy agency coordinating deployment, streamlining permitting process, grid modernization, and standard certificate ensuring quality and safety. Like I just mentioned you, the till date, when we are talking today, there is no standardized certification for green buildings and EVs. You know this? Each country has its own way of understanding. Like Niti Aayog has come out with its own analysis of EV and how we need to analyze what should be the grid versus Europe has come out with their own activity. And what we need to do, if you look at from the world point of view, we have to agree with all the specifications. So that's how the thing can work out. And financial mechanism, feed-in tariff, generating attractive returns, tax credits, green bank, mobility, public-private capital, and risk mitigation instrument for emerging markets. Then capacity building, technical training program for workforce development, research and development funding for innovation, resource assessment program providing reliable data, technology transfer facilitating knowledge sharing. These are the important points. And public engagement, awareness campaign highlighting sustainability benefits, community participation in project planning, education program at all levels, and demonstrating project showcasing success. So these are very important, and especially the fourth one is very critical, demonstrating projects show causing success, because that helps people to accept it and then also implement in that line. So so these are few things, so I just want to take it out. So the main thing here is, if I look at the imperative of path forward for green energy for foundation of global sustainability, is the comprehensive examination established that the green energy is not merely one option among many for future energy demand. It is an indispensable prerequisite for achieving sustainable development in the 21st century and beyond. The convergence of climate impact, development aspiration, energy security concerns, environmental protection needs creates an overwhelming case for rapid, large-scale renewable energy deployment across all nations and economic sectors. Fossil fuel-based energy paradigm that powered industrial civilization for 2 centuries has reached its natural terminus. Continued reliance on coal, oil, natural gas is incompatible with limiting warming of 2 degrees Celsius. I told you that. If 1.5, not 2, 2 they are very positive, but no, it's 1.5. Protecting human health from air pollution, ensuring long-term energy security, or providing affordable energy access to billions of underserved people. The choice facing humanity is not whether to transition to green energy, but how quickly and equitably this transition can be accomplished. So, so there are a lot of things coming. So I just want to skip this. I don't want to go here. Let me take you directly to, because yesterday somebody was asking me about green bonds. So I'll just share this with you for a minute, and then we will enter the activity of, the EVs and the buildings. Okay, that's how we have to work out. Now you're able to see this presentation. Green finance driving AI and renewable energy for sustainable development. Are you able to see this?
Yes, sir.
बाकी सब लोग हैं या नहीं है? I can only hear one ma'am saying.
No, sir, everyone is present here.
Present.
Yeah.
Okay.
Yes, sir, we are listening.
Voice is coming, sir.
Okay, good. So now, if you look at green energy, now I wanted to take this small topic before we enter that activity, because finance is a very critical thing. So yesterday somebody mentioned about finance, and it's a very important thing he mentioned. Now, how green finance mechanism fosters sustainability in emerging economies through artificial intelligence, renewable energy transitions. Now, what is happening here is, if you look at emerging economies like India, a research was done where they analyzed till 2015-2022, representing 40.92 of the global GDP. They are facing huge environmental challenge from rapid industrialization, huge environmental challenge. And the post-Paris Agreement era, we are being forced to implement, not them. Now, that's a very important point. We are being told, emerging economies are told, you have to implement, but majoritarily they are contributing towards CO2 emissions. The pressures of economic growth with environmental protection while addressing inadequate financial resources and outdated infrastructure is the biggest challenge the emerging economies are facing. That's the reason we have to stand on our own feet. We should not depend on others, but let's see what things are going to happen. So what is green finance? Green finance is a financial mechanism directing resources towards environmental friendly initiative, renewable energy, energy efficiency, and eco-conscious infrastructure. The key instruments are green bonds for climate-friendly projects, environmental protection expenditures, and sustainable investment. Like if you look at social development indicators, impact 1% in green bond insurance versus other thing being built up. So there's a direct impact. So the green finance positively contribute to the sustainable development. AI, artificial intelligence, act as a channel through which green finance enhances sustainability, because if you have already predefined data points, it helps you. It's a self-learning technology. And renewable energy mediation, renewable energy capacity mediates the energy green finance sustainability relationship. So if green energy capacity is not there, there will be no effect at all. That is true. That way it mediates, not moderates, right? If it is capacity is high, then only the relationship takes into place. And then serial mediation. AI links green finance to renewable energy capacity, amplifying sustainability impact. So AI is helping in multiple things, like in demand side, investment in AI for smart grid, renewable system, green building, and sustainable transportation is helping them. Supply side reduces financial barriers, attract resources, support R&D and extend economic expansion. And impact is 1% increase in green finance yields around 0.14% growth in AI development. So AI applications are predictive analytics for energy distribution, smart sensors in green buildings, route optimization for transportation, and climate modeling and monitoring. And if you look at further enhancement, you see solar power, green bonds fund large-scale solar installation, reducing capital cost and improving feasibility. So if you see Indian solar companies also, they're using huge AI, plus they're getting a lot of green bonds fund. Wind energy long-term financing aligned with extension payback period, making project more viable, because green energy projects currently are not viable at all. If you look at internal rate of returns, even net present value depends upon if you have multiple projects versus single projects. It's not positive at all. So sometimes long-term financing, they help them to generate break-even at least. And then hydro system, environmental protection, expenditure support, infrastructure development, and grid integration. So this is what it helps green financing. And this is already I told you that how AI helps to develop that activity. So there's a small thing I just wanted to mention, a small part, because somebody asked what green financing is. So I said, okay, I'll just take a minute to make you understand what green this thing is. And then there's one more thing I just wanted to show it to you. I'll show this one later, but let me start with the most interesting part is green buildings. Now, what is this green buildings here and why it is so important?
Sir.
Yeah.
So your presentation is not visible.
Yeah, I'm just showing the presentation now. Let me start with building and then we'll come to this activity. Yeah. Good. Now, oh, sorry. Yeah. Let me start it. Able to see green buildings?
Yes, sir.
Excellent. Now, if you look at green buildings in India, now, what is green building, right? Buildings are buildings. Whatever you do, energy is consumed both for when you are constructing it and also utilizing it. If you look at India, the industrial sector is the largest consumer of electricity, followed by domestic, then agriculture, and then commercial sectors, with recent data showing that industry at around 41 to 42%, domestic around 24 to 25, agriculture 17 to 18, and commercial 8 to 9 of total electricity consumption. Overall, primary energy, coal remains dominant with significant share from petroleum, natural gas, and growing renewable contribution, while specific fuel uses vary, like HSDO for transport and LPG for domestic utilization. So if you look at India consumption of energy, coal is 45, lignite is 1, crude is 31, natural gas is 8, electricity from hydro, nuclear, and others are 15%. And who are using, and if you look at the, if I took one thing called coal is used 64% in electricity, Other is non-cooking, bricks, fertilizers, sponge, iron, textile, paper, cement, steel. These are the places that they are used. If you look at different sectors, as I told you, industry, agriculture, domestic, commercial, traction, railways, and others, these are the percentage which is happening, and it is keep on increasing. If India is in the path of 7% GDP growth rate, this is keep on increasing. The consumption going to increase. And that's the reason we are saying that nothing wrong in increasing energy consumption, but the energy production has to be green. So, but why green buildings is more important? Buildings are responsible for 40% of the worldwide energy flow, and material use. Conventional buildings have been identified as the largest source of greenhouse gas emission, even more than that of a transport and industry sector. This research was done in developed country, not in emerging market, but I'm just mentioning you in developed country, if you look at which are the highest percentage of CO2 emission, 40% of, if you look at worldwide energy flow and material use, conventional buildings have been there. 8,000 lbs of waste are typically thrown into landfill during the construction of 2,000 square feet of home. So I'm making a 2,000 square feet of home. 8,000 lbs of waste are typically thrown into a landfill during the construction. Buildings in the US consume more than twice as much energy as all cars in the US. So you can imagine, no? That's a very, very, very dangerous sentence which I'm telling. Building in the US consume more than twice as much energy in that. And building accounts for 68% of the total electricity consumption in US, because if it is cold, you have to use heater. Building use 80% of total drinking water consumption in the US, and indoor level of pollution is commonly 2 to 5 times higher than outdoor pollution levels, which is actually opposite in India, right? Yes or no? Those who are from Delhi will understand. Outside you don't go, you stay at home, right? Yeah. But what might be the reason? Why indoor pollution is more in US rather than outside pollution?
Maybe because of excessive use of chemicals like sprays or
Sprays are there, but what normally we do, it's about warming up the house. So you use boilers, you use electricity and other activities. So these are the things which happens. So green buildings, also known as green construction or sustainable building, expands and complements the building design concerns of economy, utility, affordability, durability, and comfort. That's how we define green building. A green building is one which uses less water, optimizes energy efficiently, conserve natural resources, generate less waste, and provides healthier space for occupants as compared to conventional buildings. Green buildings are designed to reduce overall impact on human health and natural environment. So naturally, if your things are fine, so you can do that. And using energy, water, and other resources efficiently by reducing waste, pollution, and environmental degradation. So this is the basic definition of green building. So if you look at carefully, any green building using less water, optimize energy efficiency, conserve natural resources, generate less waste, and provide healthier space. But if you go back to history, see, this green building actually started in 1960 when an American architect called Paul proposed a new concept for ecological architecture. So when in civil construction, those who are in civil engineering must have heard this, something called ecological architecture. Ecological architecture was started by an architect called Paul, and he defined something called architecture has to be ecologically sensitive, and that's the reason he defined this word called ecological architecture. From there, the green building word came. In 1969, because in 1960, nobody was bothered about green, yeah? So you saw the video also about oil. Oil was the king, yeah? In 1969, American architecture, Lan McGrain wrote the book, Design Mitigates Nature. And this is one of the most, if you get time, I would request you to read this book, a very beautiful book. And today, which I'll show you in the next slide, the designs of green building actually comes from the American architecture Lan McGrain book on Design Integrating Nature, which marked the official birth of ecological architecture. So Paul defined ecological architecture and defined it with a parameter. Then 69, an American architecture, he wrote a book on Design Integrate Nature, a very beautiful way of looking at it, which gave the birth of ecological architecture. In 1970, the energy crisis caused various building energy saving technologies such as solar energy, geothermal energy, and wind energy to emerge, and energy saving buildings became the forerunner for building development. And the reason it happened was because oil price increase and coal. So that's how in 1970s, and you know very well, 1980 there was a world depression. India didn't suffer, but world US majorly US suffered recession, which helped industry called IT industry to grow. Correct. Then you had 81 company like Infosys getting registered and things like that. So this is how the things started to come into place. So started in as a 1960 as ecological architecture. In 1980, the World Conservation Organization put forward the slogan sustainable development for the first time. At the same time, the energy saving building system was gradually imported and it was widely used in developed countries like Germany, Britain, France, and Canada. So Europe actually copied from USA, but US never implemented. Very interesting, huh? So US started the idea from US, but implemented in Europe. That's how sustainable development came from there. In 1987, United Nations Environment Program published the Our Common Future report, which established an idea of sustainable development. And in 1990, the world's first green building standard was released in the UK. So UK became the first country to have a green building standard, correct? Do we have any green building standard in India?
Not much
Hello.
idea. Not much idea.
No, we are still developing it. We are just telling it is municipal who decides that you need to have something called rainwater harvesting, correct? All those things. Do not have. We know what not to have rather than what to have. So, like glass buildings, so the taxes will be more there and things. Very funny, but that's what it is. In 1992, because of United Nations Conference on Environment and Development promoted the idea of sustainable development, green building gradually became the direction for development. 93, US created Green Building Association. 96, Hong Kong introduced green building standards. This was due to the local problem they had. 1999, Taiwan introduced green building standards. 2000, Canada introduced. 2005, Singapore initiated BCA Green Building Mark. And 2015, China implemented the Green Building Evaluation Standard. So China had their own standard of doing it. Look at how many standards they had, how many standards in green building they have. So this is a normal thing, like what type of paint to use, what type of floor and things, carbon monoxide alarm, correct? Light colored. If you put carbon monoxide alarm in India, Indian kitchens every time is going to run. Whenever we are doing some choke or something of that sort, there's going to be a huge problem. Insulation, how should be the insulation, where the flow need to be there, light colored exterior walls, energy efficient low E windows and glass, correct? Metal light colored roofing, building trees with shade and east and west. These are the interesting things come, like where the trees has to be. You will be astonished that the green standards talks about which part when you're constructing a house or a building, in which direction there should be more trees. So naturally, I'll have more trees in east and west. What type of color should be the tiles, correct? How much should be the size of the windows? What should be the paint activity? How to do the rainwater collection? So all these things are we define as green standard. Like for example, minimum carpet use, correct? So all these very interesting way to look at this is called green energy. So each standard country-wise have different standard of green energy, green building. So make sure you read each country standard of green building. So main thing here is when you look at green building, it's a concept of sustainable site planning, building design optimization, energy performance, renewable energy utilization, sustained building material, and health, well-being, and environmental quality. So the main objective of green building is protecting occupation health, improving employee productivity. So if you have a green office, naturally output is going to increase. Green energy, water, resource are efficient, reducing overall impact on environment, optimal environment, and economic performance, and satisfying quality in indoor spaces. To understand that, let me ask you a simple question. You know Apple? Some of you must be having Apple products, right?
Yes.
Yes or no?
Yes.
Yeah. What is the first carbon neutral product of Apple and how Apple develops its building, its offices? Any idea? Any idea?
Yes, I guess they are trying to be energy neutral by solar panels.
So how they are doing?
Product, I'm not much aware. Solar panels on the buildings and the parking lot.
Okay, so that's what you're talking about. Okay, okay, fine. Let me show you how Apple is doing, how they're making their whole thing. So just give me a minute. I'll just show you this. It's very interesting way. It's very important because in that one video you will know everything, so I don't have to go further in something else. So just give me a minute. I'll just open it and just show it to you where the whole activity is. Yeah, so just showing you this. There's some problem of the volume. Mother Earth. Yeah, let me check it out. If it comes clearly in your presentation, I'll just show it to you. Yeah. Yeah.
Welcome to Apple. Welcome to Apple. Hi, I'm
She should be here any minute.
How is the
Hello,
weather
are you able
coming
to see
in?
the video? Hello, are you able to see the video?
Yes, sir. Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Hi, I'm Tim.
Yeah, I'm gonna do the offices already carbon neutral thing, right?
Yeah, all yours.
I hope we didn't keep you waiting.
Mother Nature, welcome to Apple. How was the weather getting in?
The weather was however I wanted it to be. Let's cut to the chase. In 2020, you promised to bring Apple's entire carbon footprint to zero by 2030. Henry David Thoreau over here said we have a profound opportunity to build a more sustainable future for the planet we share.
I think our 10 o'clock said the same thing.
They all do. All right. This is my third corporate responsibility gig today, so who wants to disappoint me first?
Well, we've got some updates we're excited to share with you.
Materials, status.
Is there a materials person here?
Yes, we are in the process of eliminating all plastic from our packaging by the end.
Let me guess. 50 years from now when someone else is left holding the bag?
By the end of next year, actually.
When we're also currently using 100% recycled aluminum in the enclosures of all our MacBooks, Apple TVs, Apple Watch.
What about iPod Shuffle? It's a joke. Don't you people make Ted Lasso?
Oh, that's a different group.
We're also phasing out leather in our iPhone cases.
What about Brando over there? They phasing you out too?
Oh,
What's next?
electricity.
Electricity, status.
We're operating on 100% clean electricity.
What runs on 100% clean electricity?
Every Apple office, store, and data center runs on clean electricity, thanks to you and your powerful wind and sun.
And Apple offices are already carbon neutral.
This building is carbon neutral?
Oh, yeah, we do it with a mix of clean energy and eliminating greenhouse emissions. It's kind of like if you were to.
You're seriously explaining carbon neutrality to Mother Nature?
Right, no, I'm sorry.
You want to tell me how photosynthesis works too? Don't.
Also, over 300 suppliers have committed to using 100% clean, renewable electricity.
What's next?
Transportation.
I'm proud to report that we're shipping more products by ocean rather than air, which reduces transportation emissions by 95%.
95%? Not too bad.
I'm also happy to report that we're investing in projects around the world that protect the Earth's soil, plants, and trees.
Everyone says they're planting trees.
We've planted forests.
Oh, hello.
Where?
Paraguay, Brazil.
What, are you trying to save the tropical savanna?
Yes. And we've also restored mangroves in Colombia.
What else?
Grasslands in Kenya.
Why?
Our aim is to permanently remove carbon from the atmosphere.
What about your water usage?
We've reduced it.
By how much?
63 billion gallons.
63 million?
Billion.
As you can see, we've innovated and retooled almost every part of our process to reduce our impact on the planet. But there's still a lot more work to do.
And there's something else we wanted to share with you.
You're not trying to bribe Mother Nature with Apple swag.
It's...
What was it? Can you tell me what was that product?
The Apple Watch.
So why they are showing it to Mother Nature?
Also, because they are showing it as a carbon neutral product, first product of Apple that is carbon neutral.
Carbon neutral, yes.
Yes, sir.
You're not trying to bribe Mother Nature with Apple swag.
It's Apple's very first carbon neutral product.
I want to see you do more of this.
You will.
When?
By 2030, all Apple devices will have a net zero climate impact.
All of them?
All of them.
They better.
They will.
Okay, good. See you next year. Don't disappoint your mother.
Yeah, look at the nature, the environment. The whole energy building of an in. So if you look at carefully, there are multiple things as we discussed earlier. When you look at from the building point of view, there are the different objectives from health to productivity to energy, water, resources are used more efficiently. So let me ask you one quiz question. How many billion gallons of water did Apple save? How many billion gallons of water did Apple save?
I think it's 63
billion. Very good. I mean, you all were listening. Good guy. Then reducing overall impact on the environment. And you saw the offices, like how green they are, correct? And satisfying quality indoor spaces, optimal environmental and economic performance. And to do that, the fundamental principle of green buildings are structural design efficiency, energy efficiency, water efficiency, material efficiency, and waste and toxic reduction. Then you have some structural design efficiency is the concept of sustaining building as the largest impact on cost and performance. And energy efficiency is layout of the construction that can be strategized so that natural light goes for additional warmth. And shading of roof with trees offer an eco-friendly alternative to air conditioning. So these are the few things like water efficiency. To minimize water consumption, one should aim to use water which is being collected, used, purified, and reused. Material efficiency. Material should be used that way. Can be recycled and generate surplus amount of energy. Examples are solar power panels. Not only they provide lighting, they also use energy resource, and waste and toxic reduction. It's probable to reuse resources and may waste us a benefit of something else. So to understand that, I want to show you that how energy buildings are taking place and how they are managing it. So give me a minute. So this is a small link which is talking about how Europe is doing it. Okay, so just want to share you this. Are you able to see this video?
Yes, sir.
Yes. Have a look.
The targets are so aggressive that nobody expects you to get there, but getting almost 10% close to it is really doing the impossible, and people feel and will be rewarded for that.
Success in climate tech is all about driving cost and performance innovation. So the new green alternative out-executes and displays the brown alternative.
Us being here now at the Global GBB Summit for the fourth time, it's really a different vibe from when we started 3 years ago. What we see now is more mature ventures, fewer of them, but many that have come to a really critical inflection point or scale or disappear.
Sustainability is interesting, but it's not enough. You have to be able to provide demonstrable improvements, not just on a sustainability side, but on a financial and a performance side. And frankly, that's where we're seeing most of the uptake by the brands.
We think we are in a new operating model that is the next lean era of change, and winners needs to figure out what is this operating model.
Execution, it's delivering assets, scaling production, driving down unit costs, and taking out risk, frankly. And this is what the summit is about.
It's a key opportunity for finance to bridge the gap between businesses that have a solution that works, that is cost competitive and that can be commercialized, and the infrastructure of the future. Finance can provide the capital, and operational savvy investors can also contribute with their experience and back the founders into going through that process.
So the big challenge now is to scale this technology. We've come to realize that now we have fantastic vehicles that are either close to or zero emission vehicles, but scaling does not happen at the pace that we would like to see.
Whatever the contracting strategy is, will set the tone for the entire project. We realize we have to grow together with the industry, no matter the raw material supplier, but also the equipment suppliers.
Culture is foundational, strategy sits atop it, and we think financial alignment sits on top of that.
So I see a huge opportunity within Europe on that. I believe we have the regulation that had been working over the last 5-10 years, and that means that for technologies that been lucky that they were able to raise capital before 2021 and bring those technologies to something like they are proven now.
So this is a small thing where the green era.
The challenging news is we actually have to deploy those technologies at scale. And that's really what all of what we're doing here is about, coming with ideas and concepts and concrete examples of how we can do that. The good news is most of the technologies we need to actually dramatically reduce emissions and improve circularity and pressure on nature, most of the technologies are there.
So we have green steel. So we are using hydrogen, green hydrogen to produce steel. So at least in India, and actually started producing green hydrogen to produce things. So these are something very interesting thing and activity which are coming to place. So what we'll do now here is, let me come to the last session today. And the last session, we are going to discuss a very interesting topic, which is called mobility. Because when you look at mobility, you talk about vehicles and how do we manage vehicles and mobility activity. So emerging mobility technology present tremendous potential for safe and accessible improvement in urban mobility, but also in public and private sector work together to develop mobility strategy throughout the balanced way. There's a very interesting way of how BCG crafted mobility, because a subset of mobility is called green mobility.
I'm Manveen Rana here at Davos 2024, and I'm joined by Paul Farrell, who is the Executive Vice President and Chief Strategy Officer at Borg Warner. Welcome, Paul. Thanks for joining us.
Thank you very much.
Tell us about the world of e-mobility at the moment. I mean, how much has changed recently, and where do you think we need to get to?
Yeah, no, it's a great question. I mean, it's a space that's changing a lot, right? There's really been a lot of growth. Just to put it into context, if you go back just 3 years, so 2020, 3% of vehicles produced, light vehicles produced, were electric vehicles just in 2020. If we fast forward just to last year, that's now up to 12%. So really significant gains in a relatively short period of time. So, you know, I think we've moved from early adopters and we're starting to get into it being more of a mainstream technology. So, and we expect that growth to continue in the coming years.
What do you think the challenges have been? You know, why has it been so slow for people to adopt? And what are the challenges that still exist? How do you get it past that 12%?
Yeah, I think there were a lot of challenges early on. That's clearly evolved. But there's still, those challenges still exist. If you take a step back and you think about the internal combustion engine, it's been around for over a century, right? And all the infrastructure and just consumer adoption, all that people are comfortable with that. And so now in a very short period of time, we're trying to make a big change. Maybe it still feels like it when you're driving down the road that it's the same, but it's quite different. So if in the auto industry itself changes the products you have to engineer, changes the production processes, changes all the supply chain. So it's a big shift, all while you're still doing all the other things you were doing before. So there's a big change in the auto space. Consumers have to get comfortable with slightly higher price points at least for now. And also with charging, you know, that's an area where everybody's still like, all right, is this really going to work? And so that's on the consumer side. And then you've got the infrastructure question, which ties back into charging and other things. So all those things have to come together, and it ebbs and flows, right? So I think it's natural that you would have these mismatches in supply and demand, but I think the trend's very clear. And where, you know, you ask, where do we need to go? You know, the EU just recently put out regulations last summer that said, all right, by 2035, all new vehicles will have zero CO2 emissions. So they've probably set the bar. Others, that trend has been in place for a long time, improving fuel economy, reducing CO2. But I think that's the direction. Different spaces will go, or different regions will go faster or slower. But that's clearly the ultimate, I'd say, endpoint in terms of decarbonizing transportation.
Have the infrastructure changes been fast enough? Are they still?
I think that's actually probably one of the bigger lags. You know, you can see it with Tesla, for example, where they have an established infrastructure and it works fairly well. But if you don't have a Tesla, it becomes there's anxiety there, right? And even just in terms of uptime, reliability are also challenges. And so that's where I think there's a lot of work to do. The vehicle manufacturers are now putting out a lot of new models. There's a lot they're starting to pick from. But still, people have to get comfortable that, okay, I spent a lot of money in this car. Can I actually use it in a practical way, day in and day out? So I think that's an area where you'll see a big uptick and a big emphasis just in the coming years. I mean, you see it with the IRA in the US, and I'm sure it's similar in other parts of the world.
And for you at Borg Warner, how are you sort of combating these challenges, whether it's sort of the consumer and how they view it, or whether it is infrastructure?
So for us, we're a propulsion company. So whether we like it or not, we're in the middle of all of this. So we're a company that has over 100 years of history, very much tied to the internal combustion engine. And so it's a big shift also for us. And we started that journey a little over 8 years ago. And I actually came to Borg Warner with one of the acquisitions that was really foundational to support that journey, that electrification journey. But in 2021, we announced our Charging Forward strategy, which is really focused on is growing our portion of our business that supports the electric vehicle space, both organically and through M&A, and also reducing our exposure to combustion vehicles, or the combustion business. And so we've been making steady progress on that. We've been very successful, I think, in leveraging the assets we had and growing the business organically. And then we've made, in the last 3 years, 6 acquisitions and also announced a JV, all supporting that strategy. And then in parallel, we spun off a portion of our business last summer to reduce our exposure on the combustion side. So it's a very high priority for us, as you would imagine. Again, I think we're making good progress. A lot of work to do. Big focus on execution. You know, now the rubber's really hitting the road, but we really feel like we're well positioned for the e-mobility future.
And if you think about the change that's already occurred in the last 5 years, where would you like to see this industry end up in 5 years' time?
5 years. So what are we looking at?
Or 10?
The 10. Well, you can pick
Give us either.
pick 2030 or something, right?
2030,
Pick
let's
2030.
do
Yeah. I think as we look out, we would expect you'll get different views, right? And it's hard to predict the future, but probably close to 50%, high 40s of EV penetration. It won't all be done. And even at the same time, if you look at all the vehicles that are on the road today, there's a lot of vehicles on the road that have internal combustion engines. So there's a lot of work to do to continue to support those vehicles. Half in the future will have an internal combustion engine in 2030, but that, in terms of growth and just transition in technology, electrification is clearly the major trend and a top priority for us.
That's great. Thanks so much for joining us here to tell us all about.
So this is about how current mobility is happening, about challenges like mobility and traffic. If you look at carefully, 154 hours of time is lost on traffic jams every year, and 20 of the world's most congested cities, which includes India. So climate change and pollution, 90% of the world urban population lives in an environment that fails to meet WHO air quality standards. We all agree, right? Wherever we are. Road safety, more than 1.3 million people die each year as a result of road traffic crashes. And urbanization, 63% of the world population will be living in cities by 2050, and 41 megacity will exist by 2030, out of which 6 will be from India, 7 will be from India. So if you imagine these things coming, these are the challenges being faced, and connected vehicle will account for 100% of market share by 2035. Automobile manufacturing is moving from focus from hardware to one of the software. It means the car will operate more like smartphones and providing over-the-air connectivity, guidance, upgrading, and boosting productivity for travelers like air taxis. Autonomous cars will emerge in the next 15 years with high driving, level 4. 10% cars sold in 2030 will be automated cars, autonomous car, self-driving cars, and robot taxi in the form of shared autonomous electric vehicles and autonomous mobility on demand, promise to help unlock discretionary incomes and overcoming pollution, parking, and safety issues. Shared mobility offering will account for 15% urban trips by 2035. Shared mobility includes ride pooling, ride hailing apps, car sharing, micromobility, e-scooters, and bicycles. It's mostly fully achieved by mobility as a service approach and apps that allow users to plan, book, and pay for the best point-to-point travel across modes. And the interesting part here is electric vehicles will account for 35% of the new car sales in 2035. Electric vehicles are gaining viability as solutions that tackle the pollution problem head-on. Industry investments are expanding in the range of EV by boosting the power of reducing cost of electric batteries and by improving the charging infrastructure and experiences. So these are the few things, like I just want to tell you what is happening in mobility, especially urban mobility, the challenges, and a few solutions which are currently coming in the line, and how the things are changing and things like that. Now, to understand things more better, so you have to understand from the customer's point of view. Are you able to see this driving customer centric as electric vehicle strategy at Ford? Are you able to see this thing?
Yes, sir.
In this, one thing has happened amazingly, like how Ford Motors is developing a customer centric electric vehicle strategy. So have a look and do this.
Today, the automotive industry is in the midst of unprecedented change and uncertainty. Amongst this setting, it's critical that automakers truly understand their customers. Here with me today is Mark Dipko, Head of Electric Vehicle Product Marketing and Strategy at Ford. Mark, thank you very much for being here today.
Pleasure.
Maybe to get us started, can you talk about why it's so important for Ford to truly take a customer-centric approach to developing the electric vehicle strategy?
Yeah, as you mentioned, there's so much has changed since this electric vehicles came into the market. We have two great products. We have the Mustang Mach-E and the F-150 Lightning as our retail products. And they're phenomenal products, and we talk to those customers and they love them. But then when we would talk to EV intenders, we saw this completely different perception of electric vehicles. And we saw this big difference, this big chasm between what an intender thought and what an owner thought. And for us, we really wanted to dig down deep into that and understand what was preventing those next generation of intenders from moving into EVs.
So how did you go about developing a deeper understanding of these potential electric vehicle buyers?
Well, this is where we engage with BCG, including the data scientists, to really take a much deeper analytical look at where customers were, how they were using their vehicles, how close was charging infrastructure to them, and really applying those analytics to better understanding their behaviors. So you have what they say in the surveys, but then we actually use data to understand what they were really doing and what the reality was.
Can you maybe talk about some of the critical insights that you found throughout that journey?
The top one I think that was really important was everyone's focused on range and kind of range anxiety, but what we really kind of talked about it's charge anxiety. The other was just their confidence in the product, particularly in the battery, and if they were going to get stuck with the battery. And then some of the other ones were around, were they going to get the right level of support? And what we really found was home is where the charge is. We're going to take care of charging at home, and we're going to install a home charger for you. That's the unlock to a great EV experience.
Excellent.
We focused on a battery warranty to make sure that they knew that you're not going to get stuck with the battery. It's warranted. And then I mentioned like knowing that they had someone, so we offered 24/7 live customer support. That's why we called it the Ford Power Promise. It really was us standing behind the customer and said, we have your back. We're going to make sure that when you choose to buy an EV, you're going to have a great experience if you choose a Ford.
Can you talk through the results of what you ended up seeing from that Ford Power Promise?
Since we launched in market, we've seen our sales growth hit records starting in fourth quarter of last year. Mustang Mach-E remained number 3 selling EV, and F-150 Lightning the number 1 selling EV truck in the market. And I think one of the keys to that was engaging our dealer network early in this. And what the most interesting thing when you look at this in terms of the retail network is this gave the salespeople something to talk about that was different than our competitors. And it was something that was very compelling. It was really addressing what the customer's pain points were right up front, and giving them the confidence to go ahead and buy that electric vehicle.
Obviously, the results speak for themselves, so it's no wonder why Ford ended up choosing to extend this into 2025 and actually expand it over into select European markets. What were some of the key reflections that you had both in the development and the implementation of the Ford Power Promise?
I think number one is making sure that you're not just looking at data, but you're driving towards insights. And for me, the push that we always had with the team is let's do the analytics, but let's try to understand the motivation. And then second is being able to use those insights to drive strategy and move very quickly to implementation. I think that's one of the things I'm most proud of with this team is how quickly we were able to take that, ideate around it, and get it into market.
Great. Well, thank you very much for sharing those insights, Mark.
Thank you.
We understood that how customer centricity helps to develop those activity and process together. So that's one of the things I just wanted to. Now, in the final part, we want to discuss something very basics of electric vehicles. And one of the thing which comes in electric vehicles here is, if you look at carefully, is the cost. And as you have mentioned in the video, there are multiple things which are there where those things have been taken care of. So if you look at carefully the basics of electric vehicles and how things, hybrid electric vehicles, and so EVs actually have multiple divisions like battery electric vehicles and plug-in hybrid electric vehicles. So there are two basic segmentation which comes there, hybrid as well as electric vehicles. And in this sense, you can talk about that region and how things takes place. And but the main thing which I wanted to tell you here is the different charging levels and different cost of installation. But overall cost now, EV is planning to reduce it in a very, very big manner. And the cost comparison, if you do around $14,500 fuel saving happens when you have a battery drivers over 15 years period, around $14,500. So it comes to approximately 1.4 crore rupees is saved by drivers if you work on the fuel saving cost. 3x efficiency. Electric driver trains are more than 3 times as efficient as conventional engines. And cost per mile, 2 cents to 6 cents. All electric vehicle cost 2 to 6 cents per mile versus 10 to 15 cents for conventional vehicles. So there's a huge difference. So if you look at incentives, I think so the whole activity and things would take care. Okay. And then impact wise, all electric plug-in. So electric emissions are 0 in all electric. Plug-in, there are mix. Hybrid, there is a mix. So, and gasoline, there's a thing. So people want to shift in all electric and plug-in hybrid. So that helps to match thing. And then you focus on rigorous safety testing, minimal maintenance, long battery life, and extending brake life. So these are the few things, and these already have covered that when you want to work out, these are the things like training, site planning, charging strategy, incentives, equipment selection and timings are more critical. Okay, so I'll stop here now. So any questions you have, I'll be happy to answer. Any questions you have? So we are already 8:25, 26. So any other questions you have, I'll be happy to answer. Today there are 78 people, right? Yeah. Nothing? Done then.
Sir, I have one question. What all challenges are there in Indian market of accepting electronic vehicles?
Two challenges. One is the charging stations, and the second challenge is as the cost difference is very high. The willingness to pay versus a normal gasoline vehicle versus electric vehicles is approximately 50% difference, even after subsidy. So government has to give more subsidies, more sustainable activities, so that will help people to accept. Nowadays, plugins are coming in a big manner. So let's see, it will take some time. The government of India is investing into every 200 kilometers, there'll be a charging station. Home plug-in is more important. We are actually implementing more of a Ford model here in India. That will be more successful.
Okay, thank you, sir.
Done? Chaliye ji. Then it's great to interact with you all. I could not see any one of you, but I hope you could see me. And so keep in touch and do good research and good teaching that you are motivating. Okay then. Thank you so much. Take care.
As we come to the concluding part of this session of our FDP, it is my proud and privilege to propose a vote of thanks. I extend our heartfelt gratitude to our esteemed resource person, Dr. Prashant Salwan, for delivering such an insightful and thought-provoking and inspiring session. Your insightful explanation of the concepts and real-world examples and emphasis on sustainability and economic transformation has added immense value to this faculty development program. The session was both thought-provoking and practically relevant. We sincerely thank you, sir, for sharing your expertise, valuable time, and knowledge with us.
Thank you so much, ma'am. So kind of you. Yeah.
Thank you so
I
much.
thank Sagar University to invite me, and especially the Vice Chancellor, sir, Professor Thakur, sir, to give me this opportunity to interact with you all. So thanks a lot. Yeah. Thank you. Take care then. Bye.
Thank you so much, sir. Thank you.
Thank you.
Okay, good night, everyone. Now we'll meet tomorrow.
Good night, sir.
Good night.